as I was discussing with you regarding the set point, so basically stream 82 molar flow will always be adjusted by the source 81. So the one well that you have simulated, whatsoever will be the molar flow rate in that particular stream will be the molar flow rate of the 82. In this set point you can give the parameters as well. I will discuss this one later on with you. It can have the user variables or the nodes, those are the most important thing. So I'll go to the connection. So if you will see in the screen, so the 81 is defined 32.70 mmscfd, the molar flow. So the molar flow of 82 is 32.70. Another thing is that easy way to define the temperature and pressure of all other wells is that you define those all new material streams of 82, 83, 84, 85 up to 89 from 81. But another thing is that you can add up another set point here. So you can, what you can do is you add up a set point here, you go to the set point, like this is a set point 9, you will select the variable. So for example, I select 82. Here is a list of properties that I can select. So for example, I'll go for the temperature or the pressure. So for example, I'll go for the temperature. So I've selected the temperature, that material stream 82 temperature should be the object, and it should be set by the source connection will be 81. So whatsoever will be the temperature of 81, now it is going to be the temperature of 82. So if you go to the 82, it is 120.01, so it is 120.01. Same you can go for the pressure as well. So as many properties as much you can set over there, it depends on you. Then there is an adjuster. So for example, if you are having a less amount of the gas or the oil that is not matching up with the PVT sim data that they have given you, that through the different flash systems, multi-stage flash system or the single phase flash system, single stage, sorry, I just put the wrong wording. It is not single phase or multi-phase, it is actually multi-stage or the single stage. So as we define in the single stage that this much amount of the gas should be recovered through the flashing, you can also adjust that one through this adjuster icon. So this is all for this video. Hope you will learn a lot of things from here. Please like, subscribe this channel. It will be an informative channel for you guys, and you will learn a lot of things about the oil and gas industry, that how it works and how things are defined in there. So later on what I will do is I'll also this is just one type of the Aspen module that we are looking for, looking into it. Later on I'll discuss a couple of other things like flare system, blowdown and depressurizing in this one, and how we install a pressure relief valves and how they work, how we build up the case scenarios, and how we generate the heat and material balances. Another important thing that I would like to discuss with you people here is that once this simulation is generated, so we generate a heat and material balance. Later on we define the PFD, we generate the PFD for a new system. This is the engineering cycle. Then we go for the PNIDs. Just before the PNIDs, what we do is we'll just preliminary design the PNIDs based on our control philosophy, putting the PITIs and all those things, instrumentation. Later on what we will do is we'll define the material of construction. Then we will give the line numbers for those pipelines. Then we will define that this line is just for this material. Like for example, if you are going for the oil and gas or material stream, so you'll be defining that material stream with the carbon steel. But if you are going for the the slopes lines, slope lines are usually they can be FBR, they can be cement lined. It depends on the material of construction because of the fluid that they are passing. So this is all that I have for tonight. So hope to see you again.